Hey guys, welcome to another A-Level Maths revision video. Today we're taking a look at some Year 2 material, Trigonometry and the Double Angle Formula. So, a mix of questions in here. Hopefully there's something that will help you with your exam revision. So let's just take a look at the first question here. We've got to show that Sine A plus Cos A all squared is identical to 1 plus Sine 2A. So, where do we begin with this one? Well, the only place we can really begin, if we consider the left hand side here, is by just squaring the expression. So Sine A plus Cos A times itself again. So that's Sine A plus Cos A all squared. All squared, just times together. Expand these out now. So Sine A times Sine A, that's Sine squared A. Sine A times Cos A, that would be Sine A Cos A. And then we've got another one here, Cos A times Sine A. So we've got two lots of that. So that's 2 Sine A Cos A. And then finally Cos A times Cos A would give us Cos squared A. Okay. Now at this point here, this doesn't really look anything like we're required to get. So we're going to have to try and use some identities to break it down and make it into that required form. Well, what identities can we use? Straight away, the one that jumps out to me is the fact that we've got Sine squared A and Cos squared A. So, using your basic identities, Sine squared A plus Cos squared A, that's equal to 1. So that should be a year 1 identity that you learn. So, Sine squared A plus Cos squared A plus this still, but we've still got this. And now we're just going to break down the fact that this part here, this is equal to 1. So in other words, what we've got now is 1 plus 2 Sine A Cos A. And at this point here, this is looking much better. We need to show that it's 1 plus Sine 2A. At this point here, we've got 1 plus 2 Sine A Cos A. But if you remember, 2 Sine A Cos A, this is just a double angle formula for Sine 2A. Okay, so because of that fact, this is Sine 2A, we can actually just write this as 1 plus Sine 2A, which is equal to the right hand side as required. Okay, so we've got the result that we needed to show there. And then for part B, it's a hence question, so we're hopefully going to use part A to make life much easier here. So how is it a hence question? Well, if you notice, the expression that we're asked to find the exact value of is in the exact form in part A. So, if we erase the ink, let's have another look at this one. So B here, where A is pi over 8, so it's Sine A plus Cos A all squared. So, we know that's identical to 1 plus Sine 2A. So, if A is pi over 8, 2 times pi over 8 here, 2 pi over 8, that would be pi over 4. Okay, so we can write this as 1 plus Sine pi over 4, and sine of pi over 4, we can write that in its exact form because we need to find the exact value. So we can just write that as 1 plus root 2 over 2 there. And there we have it. So you could write that as 2 plus root 2 over 2 if you want. I don't really know if that helps you anymore, but you can write it like that if you want as well. So there we have it. So that's question 1 done. Part B, not part B, question 2 here, so I'm getting carried away. We've got cos x plus sin x is equal to m, cos x minus sin x is equal to n. And m and n are just constants, so we want to write down in terms of m and n what the value of cos 2x is. So remember, cos 2x, there's multiple ways of writing it. The way I'm just going to write it for now, and this is the way I would remember it, is cos 2a, well that's just cos squared a minus sine squared a. Okay. If you write it like this, then you can manipulate using, sine squared plus cos squared. Sine squared x plus cos squared x equal to 1. You can just substitute here. But this is the one I'd remember, and then you can get the others from this. So if we just write it like that for now, and what we know is cos x plus sine x equal to m, and then cos x minus sine x equal to n. So what I'll do is I'll just write this out. So that one's equal to m. This is equal to n. Okay. Well, if cos 2x is equal to this, so just writing this in terms of x now, like so. If you notice, it's actually the difference of two squares, okay? Because this would just be cos x plus sine x times cos x minus sine x. That's just the difference of two squares, right? Which would give you cos squared x and the minus sine squared x. The other middle term here would just cancel. So cos x plus sine x is just m. And this cos x minus sine x is n. So this is m times n. So therefore, nice and easy, cos 2x is equal to mn. So like you can see, these questions are sometimes easier than they look. You just need to go in kind of a methodical order with it and break it down step by step, so it's not too bad. Okay, so that's actually just that question there. Quite a quick one actually for 4 marks. The next question here is a solving an equation one. So how would we do this? So let's have a look at it. So cos 2 theta equal to 5 sine theta. Okay, and we want to show that's in this form: a sine squared theta plus b sine theta plus c equals 0. Now you won't always be given this information, that it needs to be in this quadratic form, but that's kind of a good clue. If you take a look at what your double angle is, so in this case it's cos 2 theta, this is the one that you need to change. And the reason we change this one is because this is the one that we can manipulate using the identities. This 5 sine theta, basically, the one that isn't the double angle, that's the one that you're going to rearrange in terms of the quadratic, which they give you here, but just in case they don't, that's kind of the aim with these questions. So what I'm going to do, I'm just going to get it all on one side. So if I just take sine theta off both sides, or 5 sine theta, that's equal to 0. And at this stage here now, we can just use our double angle formula for cos. So again, just using cos 2a is equal to cos squared a minus sine squared a. And then just rearranging here using cos squared a is equal to 1. Just substituting here, you can manipulate this into a couple of different ways. So we want a quadratic in terms of sine. So for this case here, we need to use the fact that we can write this as 1 minus 2 sine squared theta. Okay, so using that information now, we can write this as 1 minus 2 sine theta minus 5 sine theta is equal to 0. Okay, so this is equal to 0 now. We can take, I'm missing something, what we're missing, I'm missing a square somewhere, yeah, that should be 2 sine squared, that's 2 sine squared there. So I want this in terms of a positive quadratic just to make life easier. So if I take this 2 across here, so I'm going to get 2 sine squared theta plus 5 sine theta minus 1 equals 0. Okay, and now at this stage here, we just want to solve this. Sometimes you'll find that it factorizes quite nicely. In this case here, you can do it by checking like discriminant, for example, or just actually having a go at factorizing it. You'll find this one doesn't go quite nicely. So in that case, we need to use the quadratic formula. So use the quadratic formula. So use the quadratic formula. So in that case, we're solving for sine theta here. So sine theta is going to be equal to minus b, so minus 5 plus or minus the square root of b squared, so 5 squared, so that's 25, minus 4 times a, which is 2, times c, which is minus 1. And then we divide that all by 2a, so 2 times 2, which is 4. And if you simplify all this, I've already done this by hand, but if you do all this by hand, you'll get minus 5 plus or minus square root of 33 divided by 4. Okay, So this is sine theta. Now, at this case here, we don't want the negative solution. You can consider this using the interval, because we are solving this for... oh, so I'm getting carried away, actually. So I'm jumping straight into part B here. You can finish part A at this point here. So this is part A, where A is 2, B is 5, and then C is -1. So I'm getting carried away. I mean, you can technically do them all in one, but this is part B here. Okay, so part B here, we can get rid of the negative solution, because we're only considering it on minus pi and pi. So it's up to you how you solve this. You can use a cast diagram, you can draw a graph, or you can just kind of solve it using basic knowledge. It's only just a sine equation here. So I'm going to take sine inverse here of -5 plus root 33 over 4. So if you do that, what you'll get is that sine theta is, so if I just do it here, sine theta is equal to 0.1861. So then we're doing sine inverse of 0.1861 to get theta. Okay, so this is a bit scruffy. So we're going to get two solutions here. So therefore, sine inverse of this, we get theta equals, and again we're in radians, just be careful for that, 0.187. And then, to get the other solution for theta, we also need to do pi minus this here. So pi minus this, in radians, we're going to get 2.954. Okay, and there are our solutions in radians. So this very last part of part B, shouldn't be anything too tricky. Hopefully not too bad there. Okay, so that brings us to the end of that question. Let's take a look at the next one. So this one, a very standard kind of, show that question and then followed up by a solving an equation question. So, question 22 here, part A. So we've got to use a double angle formula to prove that 1 minus cos 2x over 1 plus cos 2x is identical to tan squared x. So 4 marks for this. Again, we're doing this in terms of cos 2x. So cos 2x. So cos squared x minus sine squared x. So we can write this as, two different ways. You could write this as 1 minus 2 sine squared x. And we could write this as 2 cos squared x minus 1. Okay, just by substituting in whichever one you want. Okay, so using sine squared x plus cos squared x. Okay, that's equal to 1. So you can just rearrange this to be cos squared x is 1 minus sine squared x, and then just substitute it in, for example. And again, you could rearrange it to be cos squared or sine squared and just substitute it in. So we're going to take use of these to actually prove this result. So 1 minus cos 2x. Now, just as a quick note before you actually tackle this question, if you want the right hand side to be identical to tan squared x, what we're probably hoping for here is that we get sine squared x over cos squared x. That would be a nice way of doing it. So let's see if we can kind of get that to work. Well, if we've got 1 minus cos 2x, the numerator has to just be sine squared x. So if I substitute in this one here, call that 1 for my numerator, and if we substitute in 2 for the denominator, where it's in terms of cos squared x, we might actually get that result. So let's have a go with it. So 1 minus 1. Okay, so that's just 1. I'm going to substitute in for my numerator. Let's just do our denominator as well. So that's going to be 1 plus 2 cos squared x minus 1. Okay, so just simplifying here, 1 minus 1, so that'll be 0, minus 2 sine squared x, that will be 2 sine squared x. My denominator is 1 plus 2 cos squared x, can't even speak, minus the 1. So 1 minus 1 will just be 0, so we just get left with 2 cos squared x. And then, nicely, this simplifies down here to just be sine squared x over cos squared x. Which we know is just tan squared x, which is equal to the right hand side as required. Okay, so like you can see these results, you can kind of get an idea just before you start what you should be aiming for. So if you see a tan squared or a tan x or anything like that, try and think of sine squared or sine x over cos x and try and aim for that result. So that works out quite nicely. And then part B, a hence question, so we're going to use this part. We want to find all the solutions of 1 minus cos 2x divided by 1 plus cos 2x is equal to 3. So in other words, we can just write that as tan squared x is equal to 3. Okay, so this shouldn't be too bad to solve now. If we square root both sides, we get tan x is equal to plus or minus the square root of 3. Now we're solving this between minus pi and pi, so we've just got to be careful of the kind of the range we're working with here. You can draw a graph if you find it easier. So you consider what the graph looks like here. So it's going to look something like this. And so for example, if you consider both plus root 3 and minus root 3, so you were to draw it kind of like, I don't know, root 3 for example, minus root 3, that's minus root 3 there. And then just consider what happens. So that's not a minus in the there, just be careful for that. But minus root 3 and root 3, and just consider what happens. I'm going to do it by calculator. So tan x, tan inverse of root 3. What's that going to give me? So we're working in radians again here. Well, my first solution will be pi over 3. And then we can get our other solution, sorry, that should be a comma, our other solution by doing pi over 3 minus pi, because don't forget it's periodic about pi, so it's a bit minus 2 pi over 3. Okay, but let's also consider tan inverse of minus root 3. So if we just do that up here, this is part B still. Tan inverse of minus root 3. Well, again, just do it on your calculator. What you'll find is that this is equal, or x is equal in this case, 2 minus pi over 3. And then if you do minus pi over 3 minus pi, you'll get 2 pi over 3. In fact, if you add pi to it, minus pi over 3 plus pi. There you go, 2 pi over 3. Okay, so not too bad of a question. Hopefully that's helped. Let's take a look at the next one. So there's quite a lot of questions in this video. I might have picked out a few too many, but hopefully it is helping. So we just got to prove 2 more identities here. Nothing too crazy, I don't think. So this is exercise 7F, question 1, C and D. So if we do C first, 1 minus cos 2 theta divided by sine 2 theta. Okay, so we're going to have to use double angle formula for sine and double angle formula for cos here. Well, again, if we want tan theta, what we're hoping to find here is that it's sine theta divided by cos theta. So let's see if we can work towards that and get that result. So if we deal with the denominator first, the only thing we can't do is just write this in terms of the double angle formula. So that's 2 sine theta cos theta. Can't do anything more with that. 1 minus cos 2 theta. Well, if this is going to be sine over cos, what we need to do is cancel this 2 sine theta, because we need sine theta over cos theta. So how can we do that? Well, if we do 1 minus, so cos 2 theta, well, we want to cancel the 2 sine theta here, so what I'm going to do is I'm going to substitute in 1 minus 2 sine squared. 1 minus 2 sine squared theta. Right, so, and what we're hoping here is that the 2 sine theta here will cancel up here, and we're just going to get left with a sine theta over cos theta. So 1 minus 1 will be 0, minus 2 sine squared theta, will just give us the positive of it. Like so. And then at this point here, we want to see if this cancels. Well, 2 sine squared theta, that's 2 times sine theta times sine theta. So we write it out in full just so we can see what cancels nicely. And like we can see here, we can cancel this 2 sine theta with this 2 sine theta to get left with sine theta over cos theta, which we know obviously is just tan theta, which is equal to the right hand side as required. So nice stuff there. We got our result quite nice and easy. The next one a little bit trickier. This time we've got sec squared and we've got a tan squared involved, and we want to show that everything is equal to sec 2 theta. So how would we tackle one like this? Well, we just write it in a form that we know how to work with. So remember sec squared, or sec squared theta is 1 over cos squared theta. So what we can actually do is we can just write this over 1 over cos squared theta times this 1 minus tan squared theta. So I don't think I'm making much sense. Let me just write it out. Might make it a bit easier. So this is 1 over cos squared theta. So in other words, this is actually 1 over cos squared theta times 1 minus tan squared theta. So that's kind of the result I was trying to lay out here. And with this now, we can start manipulating this. If it's sec 2 theta, what we're probably hoping for at the very end is just 1 over cos 2 theta, because that's what sec 2 theta is. So let's see if we can rewrite this denominator. Cos squared theta times 1 would be cos squared theta. So this is 1 divided by cos squared theta. And then cos squared theta times minus tan squared theta. Well, let's just not multiply this straight away. Let's actually try and consider what we can do here. Tan squared theta, we know, is sine squared theta over cos squared theta. Okay, that's equal to tan squared theta. Well, if we've got cos squared theta times tan squared theta here, or minus of it, the cos squareds will just cancel, right? That'll just cancel with that. So in other words, what I actually get left with here is cos squared theta minus sine squared theta. Okay. And because I get left with 1 over cos squared theta minus sine squared theta here, we know this is one of our identities. So we know cos squared theta minus sine squared theta, we know that that is just equal to cos 2 theta. So in other words, this is equal now to 1 over cos 2 theta. And cos 2 theta, well, 1 over cos 2 theta, we know, is sec 2 theta. Just like we said we needed before. Okay? And like we can see there, that just gives us the result that we need. And that just brings us to the end of that one there. So that is equal to the right hand side as required. So nothing too bad there. And then finally, last question here for this video. We've got a final one here. So we want to show that tan theta plus cot theta is identical to 2 cosec 2 theta. And then we want to find the value of tan 75 plus cot 75. So let's do part A first, obviously. Wouldn't make much sense to do part B. So tan theta plus cot theta, well, we can't really do much with tan theta. Well, we could write it as sine theta over cos theta, actually. Sine theta over cos theta. Plus cot theta. So remember, this is the reciprocal of this. So cot theta is 1 over tan theta. So the reciprocal of this, so that'd be cos theta over sine theta. Well, you can multiply across here, so this would be sine squared theta plus cos squared theta over sine theta cos theta. So if we do that, plus cos squared theta divided by sine theta cos theta. Now at this point here, this looks kind of similar to what we need, considering that we're going to need something like 2 over sine 2 theta, because that's what 2 cosec 2 theta is. But at this point, it's kind of see how this links, unless you can spot the identities that we're using. So in the numerator here, notice that this is equal to 1, and our numerator needs to be 2. So we need 2 lots of this, and notice we need the double angle formula. We need 2 theta, okay? Well, sine 2 theta. And at this point here, this is just half of the double angle formula for sine theta, okay? Or sine 2 theta, I should say. So if we times top and bottom by 2, this might work out quite nicely. So 2 lots of the numerator, like so. And then doing the same with the denominator here, we get 2 sine theta cos theta, which is exactly what we need here, because this numerator is 2 times 1, so that's 2. And this denominator here, we know this is the double angle formula for sine 2 theta. And this result here is exactly what we need. This is 2 cosec 2 theta, which is equal to the right hand side, like we needed there. Okay, so that's just part A, and then part B is a hence question, so we're going to use this result here to work out part B. So what it's saying is that tan 75, so our theta is 75 here, tan 75 plus cot 75 is identical to 2 cosec 2 theta. So in other words, tan 75 plus cot 75 is equal to, where was I writing it? So 2 over sine 2 theta. So if theta is 75, this is sine of 150. We're working in degrees here. So 2 over sine of 150 degrees. Put this on your calculator unless you know it by off the top of your head. So this is 2. Sine of 150 degrees, that's a half. So 2 divided by, that's a half, believe it or not. 2 divided by a half, that just gives us 4. So the value of tan 75 plus cot 75 is just 4 there. Okay. So that brings us to the end of this video. I think this has been quite a long one. My hand is killing. There's been quite a lot of questions for this one. But I hope it's helped. If there's any mistakes, which there probably is, please just let me know down below.